Okay, so we come back with uh, talking about the derivative inverse trigonometric functions. So we start with an example 23, and in this example, we will use implicit differential to derive the formula. Okay, because why? We haven't have any formula to find the derivative of arcsine function, like arcsine of x, right? Or y equal to sine -1x. Like you never seen a derivative of this function. So we try to figure out how can we take derivative of this. Okay, so firstly, you should note that if y equal to x sine of x, then sine y will be equal to x. And in here we have y is in between -2 to pi/2, and we want to find the y derivative will be equal to derivative of x sine x. Okay. Next, we will in here we have to use the implicit differentiation on sine y equal to x. So yeah, because in this case you haven't have the y isolatedly already. So you need to use implicit differentiation on this. So start with sine y equal to x. We take derivative both on side. So d sine y over dx is the derivative of that function with respect to x. In the right hand side, gonna be dx over dx, right? D of x over dx. Don't think that dx over dx means this is gonna be equal to 1. I know, but basically, don't think like that. It's actually a derivative of x with respect to x. Always think like that. Okay. And what does that mean? Okay. The left hand side will give you this is a sign of a function of x. Okay, y is a function of x, so you still have to use chain rule here. So you're gonna have first thing is take the derivative of the outside function, which is sine y. So that's cosine of y. Okay, and then multiplied by y derivative. And that is the left hand side. What about the right hand side? You have 1. Okay. So for this one, you actually have implicit differentiation. Okay. So you need to isolate the y derivative alone. And use other color to isolate this guy. So divide both sides by cosine of y. You will have y derivative will be equal to 1 over cosine of y. Okay, so know that So let me have a note that we want an expression for the derivative of arc sine x, right? That just involves x, not y, right? Not y. So we need to write cosine y in terms of x, right? You need to write cosine y in terms of x. Okay, so we have, let me write that. Let me see. Okay, so we have from the identity, from trig identity, okay, from trig identity, I have cosine square of x plus sine square of x will always equal to 1, right? It's very important one that you always need to remember that. So from here, you know what? I should change to be y better for this case because later on, I can change to be x. Okay. So then from here I can have cosine square y will be equal to 1 minus sine square y. And then you have cosine y will be equal to square root of 1 minus sine square y. And this will be positive. This will be positive. On the interval from pi over 2 to negative pi over 2 to pi over 2, right? So okay. Okay, so y derivative will be equal to 1 over cosine of x, sorry, cosine of y. According from here, we can have that, right? So remember that's cosine of y, I can change it to be square root of 1 minus sine square y. Okay. And remember that according to the to the sine y will be equal to x. So then you have sine square y will be equal to x squared. Okay. So now instead of having 1 over 1 over square root of 1 minus sine square y, you can rewrite as 1 over square root of 1 minus x squared. Okay. And yeah. And then, so, derivative of x sine x will be equal to 1 over square root of 1 minus x squared. And that's from here, and from now on, you can use this formula to find the derivative of inverse trigonometric sine, right? Inverse of sine x. And um, doing the same thing, you will have like a table of formula for the derivative of inverse trigonometric function down here. So so you can take a look at that and write down, and from now on you can use this formula to apply on the derivative of the inverse trigonometric function. Okay, so move to the next page. You can see we're gonna have worksheet number 5 with exercise to try 17, 18. But let's talk about 17. What we do is we're gonna try to find the derivative of y with respect to x using the implicit differentiation of the 2x cubed minus x and y cubed equal to 3. Remember that you will use per rule here because of this term, right? So I can give you ahead with the first step as derivative of 2x cubed minus with the derivative of x times y cubed equal to derivative of dx 3. Dx 3. Okay, so remember that you need to apply the prop rule for the middle term in this column, right? And then finally later on, you try to have the y derivative. Okay. Okay, so for the exercise 18, you have to find the derivative of y plus 2, but you and also you have to use the implicit differentiation for this one. For this problem, let me see if you can, you still have to, yeah, I think also this one you have to apply the rule for this term to handle the derivative. Yep. So let's move to the next. Okay. So we also have exercise try number 19. This is an extra challenge, and what we do is we're going to find the equation of a tangent line to the curve in the previous exercise 18 at the point 1, 2. Okay, so firstly you always have to think about finding the dy dx at the point 1, 2, right? But it said a pivot exercise. That means you have to use the information from both sides in order to apply for this problem. Okay, after that, you're gonna apply on the formula y equal to y divided by 1 times x minus 1 plus y of 1. After that, you will have the answer. Okay, so I'm gonna stop for this section now and see you in the next session. Bye.